webinar. So, and also I thank the management, principal, HOD, and all the faculty members for your support to organize this series of webinars in this pandemic situation. So I once again, I thank you all for giving an opportunity for this webinar to brief about this about ICI and also this international webinar. So thank you all, and I welcome you all once again for this webinar. Thank you, Arun sir.
Sir, thank you, sir. Thank you for briefing about today's session and for your presence, sir. Once again, now I request our beloved colleague, Mr. Sunny K. sir, to introduce today's honorable speaker of the webinar, Dr. Manjunath S. Amalkar. Over to you, sir.
Thank you, sir. Good morning to one and all. It is my privilege to introduce today's speaker, Dr. Manjunath S. Amalkar, Professor and Assessment at Department of Civil Engineering and Architecture, Higher College of Technology, Muscat. He has completed BE in Civil Engineering from UVCE Bangalore in 2004 and Master of Technology in Structural Engineering from Bangalore Institute of Technology, Bengaluru in 2008, and Doctor of Philosophy in Civil Engineering from VTU on the topic Strength of Hollow Concrete Block Masonry Wall in the year 2017. He has worked as a project engineering in Arc Nove consultant and Matrix consultant for about 2 years. Later, he worked as an assistant professor in RV College of Engineering for about 5 years. Presently, he is working as a lecturer and assessment head in Higher College of Technology, Muscat. His main areas of interest were alternative building materials, sustainable building materials, and masonry structures. Many of his research projects were funded majorly. Strength of hollow concrete blocks for high-rise building has got 17.42 lakhs under VTU grant scheme, and around 5 projects were funded in KSCST for the students under his guidance. And he was the coordinator for HUDCO chair program, which is set up at Department of Civil Engineering for about 3 years, which was granted for about 35 lakhs. He has guided for about 15 MTech students and 30 UG students. He is the member of a reviewer board in International Journal of Scientific and Engineering Technology Journal. He has published about 9 papers in various national and international journals. He was awarded as Best Young Researcher of the year 2012 by IICT RVCE chapter. So on behalf of Civil Engineering Department, EWIT, I once again welcome you, sir, for the webinar. Thank you, sir.
Thank you, Sunny sir. Now it's time to start the session. Dr. Manjunath S. Amalkar sir. We are eagerly waiting to start a session.
Yes, sir.
Over to you, sir.
Am I audible, sir?
Yeah, yes, sir. Yes, sir.
Yeah, yes, perfect. Sir. Okay.
Start and share your screen, sir.
Yes, sir. Before I begin the presentation, I would like to thank the management of the East-West Institute of Technology, particularly Dr. Chennakeshwalu, who's the Principal and Director for East-West Institute of Technology, Dr. Purushottam, Director, East-West Group of Institutions, and my special thanks to the Professor and Head, Dr. Nagaraj Gupta, for having given me this opportunity to share my thoughts on the said topic. I would also like to thank Dr. L.R. Manjunath, the chairman for ICI Bangalore chapter, and also Dr. R.L. Ramesh, the secretary for ICI Bangalore chapter. I would once again thank all the management of East-West Institute of Technology for providing this opportunity. Well, I would now, having said, and also I would also thank Mr. Sunny Gowda for having given introduction. Now let's begin with the presentation. Can you see the screen?
Yes, sir. Yes, sir.
Yes, sir.
Okay, perfect. Yeah. Well, once again, welcome to all the participants for this one-day webinar. because of the pandemic situation, I think, we have had this opportunity to have the online, seminars or the webinars in order to keep our academic knowledge going. Well, on that thought, today we would be discussing about the potential of masonry structures. Well, when we talk about potential, well, in this presentation, we would look at both aspects. One is the structural potential as well as the architectural potential of masonry structure. The presentation outline would go something like this. We would look into the background of understanding the fundamentals of masonry, wherein we would like to define what is masonry, what are the advantages and disadvantages of masonry, and talking about masonry, I think one has to also look up upon it as an eco-friendly material. So we will also see what are the embodied energy and the CO2 emission, which is emitted using some of the building blocks what we have, which can be used for the masonry. And of course, talking about the potential, we would also see what are some of the examples we have in high-rise masonry, or maybe some of the examples for composite masonry, and some of the innovative structures which are of great importance. Finally, we would look into a little bit of the design concept. I would not, although it's a broad topic, I would just briefly discuss about how do we go about assessing the compressive strength of masonry in general, and I would have some numbers on hollow concrete block masonry as well. And in a nutshell, we would also look into the guidelines as prescribed by the Indian Standards 1905. Well, all of us know what is the definition of structure. As it goes, a structure is an assemblage of components, structural components, maybe beams, slabs, columns, foundations. All these are assembled together, and that is what constitutes a structure. And these are the ones which are applied, or rather the ones which resist the applied loads without any appreciable deformations. We have come across various forms of structures, and just to talk briefly about the forms which we usually use, well, one which everybody is familiar with is the framed structure, where it's also called as the skeletal structure, where the members, the structural members, like I just mentioned, the beams, the columns, the slabs, are the ones which are supposed to carry the load. Well, wall just plays a role of a partition or just an infill. So this is a typical, I'm sure each one of us have seen such structures, which is a typical RC framed structure. Well, the other option what we have is a load bearing structure, or sometimes you can also refer this as to a continuous system. Now here the loads from the slabs are directly transferred on to the walls, or through an in-plane or through the member action to the boundaries. Typically one such load bearing structure would that be of a masonry building, what we have here, where the loads from the slabs are directly resting on the walls, and the walls are the ones which are supposed to be carrying the loads. Now, having looked at the forms of structures, and let us go understanding the term masonry. I'm sure all of us have heard this word masonry. Well, we usually call commonly it as walls. And as per the codal recommendation, walls are defined as an upright structural member whose dimensions along the width are more than 4 times their thickness. Now, if I'm looking at this as an element, which I would want to call it as a wall, well, its width, has to be at least 4 times more than the thickness. Well, if this condition satisfies, that is when we can call an element as a wall. On the contrary, if it is, let us say, less than 4, then we would have to design it as a column, a masonry column, or a pier. And based on the configuration, structural configurations, and of course the functions, well, walls or the masonry can be categorized as something called as load-bearing walls and non-load-bearing walls. Now, what are load-bearing walls? As the name goes, these are the walls which are supposed to bear the loads. Well, the loads from the slabs which are being directly, placed on the walls, and the walls are the ones which have to take all the load onto itself. And then, of course, subsequently, the walls are being constructed one above the other, and they are the ones which are the members which are resisting all the loads. Well, the other option, as I mentioned in the beginning, is a non-load-bearing wall, and as the name goes again, it is one which is being used just to fill the frame, and it is not expected to carry any load. All the loads are carried by the structural members, that is the beams, and then to the columns, and then to the foundation. Well, the walls are just filling in the frame. Moving ahead, now let us understand what are the advantages and disadvantages of masonry. Well, advantages, yes, because it's a prefabricated structure. Well, there is no formwork required. There is no curing, unlike concrete structures. Well, there is a greater flexibility in terms of the plan forms. It has both functional as a structural role to play, and yes, you can say it to be economical also. Again, depends on what is the building unit is trying to use. And of course, it is durable, because we have several examples of masonry structures which have been maybe built several hundreds of years, if not more, which are even standing to this date. Yes, for that, from that we can say for sure that it is certainly durable, and of course environmental friendly, because there is less amount of energy which is consumed, and also the carbon dioxide emission is also far less than its other counterparts. Well, our disadvantages, like any technology, we have disadvantages with masonry as well. Well, it is structurally very complex. Of course, it is brittle, and because if you have to construct it for a high-rise masonry, well, you end up getting a very heavy structure for sure. And of course, there are too many other variables which are also involved, making the design a little more complex. Well, these are the disadvantages of masonry. Let us try to compare the two, material. One is the concrete here, which is the plain cement concrete, and then masonry in terms of its behavior and its composition and its distribution of its component materials. Well, we all know that concrete and masonry will agree upon being good in compression. They are both equally good in compression, and of course, in concrete, one can go about with making a better mixed design, and one can achieve a better strength, but it goes with the application. So one can say, but that both are good in compression and both are equally weak in tension. And both are brittle materials, whereas the concrete is a unimodulus, assumed to be unimodulus material, while the masonry is a bimodulus. And in terms of its composition, as we all know, concrete is made up of fine aggregates and the coarse aggregates. Of course, with a binder, well, depending on what is the binder used, you can have a cement concrete or other types of concrete as well. Well, in masonry, we look at these are the masonry units and the mortar as the two key, ingredient composition. And masonry units, you have various options. We will, of course, see a little later what are the options one have when we talk about masonry units. And of course, these masonry units have to be stitched together. So that is where the role of mortar comes in. Well, we also have different mortars which one can use for going about with the construction of masonry. And talking about the distribution of component materials, yes, concrete, it's very random. and of course, it is isotropic, having same properties at all possible sections, whereas masonry, well, the distribution is orderly, and well, it behaves like an orthotropic material. Now, what are the options we have in masonry units? Well, we have seen or maybe heard or and seen these options. Well, we have adobe, these are basically rammed earth, or which is sun-dried mud blocks. We have the stone or the laterite blocks. We use very oftenly the burnt clay bricks. Of course, concrete blocks, which can be solid as well as hollow. And you have the calcium silicate blocks, then you have the stabilized mud blocks, you have gypsum blocks. Well, there are a few more additions which have not included here. Geopolymer blocks are the new ones which have been added into the list of masonry units. Well, what is the block or what is the type of unit one has to use will purely depend on what is the requirement. And of course, talking about stitching the mason, well, you have a mortar which does the job for us, and traditionally we have been using the mud mortar, the lime sand mortar, and then after the advent of cement, we started using the cement or cement sand mortar, or sometimes we also try to use the composite mortars, which is a combination of cement, lime, sand. Of course, depending on the requirement, one can go ahead with some additives also. When talking about reinforcement, yes, we do have structures built out of masonry, and it could also be reinforced. When we talk about reinforcement, one option is of course the metallic one, which is traditionally also used. It's also used as a reinforcement in the concrete structures. Well, the same can be used even in masonry structures, but that is about the metallic option. Well, there have been bamboo sheets or bamboo strips which have been used as reinforcement, in order to make it a little better when it comes to any lateral loading. Well, I just brought up this slide here. One has to refer when it comes to any of the design of masonry or any of them. Well, this is just bought for that reason. Now, talking about masonry as an energy efficient building. Now, this is a very important aspect which has to be understood. It has to be understood. Hello? This is a very important aspect. If you look into, the ones which we have been using, the bricks, let us try to compare the energy consumed with keeping brick as a standard, and let us try to look at the other alternatives you have as a building material or a building block. Now, this particular table gives us, the amount of energy, what is required to produce a unit block of masonry unit. Now, if you look here, the amount of energy is somewhere around 3.75 to 4.5 megajoules. Well, what is that which constitutes this energy? One is, of course, the transportation cost. The other one would obviously be, if I'm talking about bricks, it would be the brick or the burning cost of the brick, rather the burning energy required to produce the bricks. Well, these are basically the two parameters which has to be analyzed, or which has to be taken into account while one is trying to find out how much is the energy required. Now, looking at the carbon dioxide emission for a brick is somewhere around 0.46 to 0.56 kilograms. And if you compare, the other alternatives as equivalent to the brick, well, you can notice that there is a significant reduction in the energy required, as well as there is a significant reduction in the carbon dioxide emission also. Well, this shows that if one can use these alternative blocks, there would be a significant reduction not only in the energy consumed but also in the carbon dioxide emission. Well, this is quite important to understand, because there is a dubious distinction. That India is the third largest emitter of carbon dioxide after US and China, but for that reasons, I think one has to be taking the environmental also into account. One has to be very conscious when we try to select a particular unit block. Well, the last column here gives you a range of strength, for various for all these blocks. However, I think the ones which I did mention, geopolymer blocks and the soil blocks, these are the new additions of masonry units. Well, one has to try to find out what would be the amount of energy which would be required to produce such blocks. Well, the strength is quite promising, which is 5 to 6 MPa. Let us look into what is the amount of energy now if it has to be used for a particular building technology. Now, keeping I have these 4 columns here. The two with respect to the operational energy and the carbon dioxide emission, these are the operational energy. So I have kept this as constant. Well, it is taken to be 9.3 gigajoules per meter square. Well, the number is got from just looking at an average Indian family using how many kilowatt hour per annum, and then looking at a period of 25 years as an operation. Well, we end up getting this value of 9.3 gigajoules per meter square. Well, keeping this as constant, let us look into the building technology and how much of energy it is used, and what is the amount of CO2 emission. Now, if I have an option like I'm going with a 4-story RC frame with a brick infill, like the ones we talked about the frame structure, well, the total embodied energy is 2.7 gigajoules per meter square. And the CO2 emission is around 0.25 tons per meter square. Now, if I have to, let us say I go with the same 4-story, but not with a frame structure, but with a masonry structure, here I have used the word SMB, where SMB stands for stabilized mud block masonry. Now, if this is an option which I'm going with, and having normal conventional RC floors, well, you see that there is a significant reduction in the embodied energy and also the CO2 emission as compared to the previous one. Now, if we have to compare the 2-story building, let's say, with 2-story brick masonry. Now, these two comparison is only among the masonry. Now, let us say I have a 2-story brick masonry with conventional RC floors. RC floors, when I say RC slabs is what I meant. It requires something around 2.65 gigajoules per meter square. If I choose rather than a brick masonry, an alternative to this, let us say I choose a stabilized mud block masonry and not have RC floors, but then have stabilized mud block masonry units itself as being used as a floor, then there is a significant reduction in the amount of total energy, which is which is evident here, which is 0.62 and 0.06 for embodied energy and CO2 emission respectively. Well, going ahead, talking about the masonry units and what are the alternatives we have? Well, this is one alternative which is being extensively used. It used to be hollow concrete blocks, which were rather the solid concrete blocks, which were being done using a very crude method earlier. But now there have been a lot of manufacturers who have kept a better quality control and who are in a position to make a good quality hollow concrete blocks. Now, what you see on the screen is hollow concrete blocks with various sizes, various shapes, and sizes for various purposes. Well, some of the blocks you can see that the holes are through throughout the height of the block. Well, there are which are not having through and through holes. They are hollow, but they are not having through and through holes, just to facilitate the placement of mortar. And going ahead, some of the again, the hollow concrete blocks also, one could also see these two types again in the market. One which is having smaller dia holes, but more in number, and the ones which I just showed previously having two larger holes. With, of course, two different sizes. The ones which are having smaller holes, smaller dia of holes, smaller voids, but more in number, we usually refer to these blocks as cellular concrete blocks. And the ones which are with a larger holes, we can refer it to the hollow as the hollow concrete block. Now, the other option is, of course, these clay blocks. There are a lot of manufacturers who are making a very good quality clay blocks, which are being used, although for mixed, as an infill as well as a structural masonry unit. Well, the advantages is it's very light. It's very light with the kind of number of holes present, and you see that there are provisions for even placing reinforcement and perhaps grouting it later, depending on what is the purpose of usage. Well, this is the one which is which is actually the brainchild of Astra, Indian Institute of Science. This is the press which is called as the Martini press, which is made used to produce the stabilized mud blocks. It was under the guidance of Dr. K.S. Jagdish, who was the director for Astra, Indian Institute of Science, who has actually designed the machine. Well, the blocks are just made by processing sandy soil with a certain percentage of stabilizer. Maybe one can use cement as the stabilizer, and then it just has to be pressed at the optimum moisture content. So one can get blocks which would look something like this. Although I do not have the picture of the block, but then I have a picture of the masonry here, which is being, or the wall, which is being built using this stabilized mud blocks. You can also see that in order to have this finish, rounded finish, one can do it here as well. One can get it done using the same press what I did mention a little while earlier. Now, not only rectangular blocks, but then one can produce blocks of various shapes and various sizes for various purposes. If you want to have it as a cornice here, so one can maybe produce blocks, and depending on various applications, one can produce blocks of various shapes and various sizes. Well, you see here the block which is having a depression here. We will, of course, discuss these types of blocks a little later when we look into the applications of these blocks. Well, we understand that, masonry, structural masonry is one of the oldest building methodologies, and by far the most resilient. Right from the Egyptian pyramids and Roman Pantheon to the Vatican and to the Baltimore, there have been stone and brick masonry that have been used to build, the world's most iconic and enduring structures. Just let us also look into those iconic and innovative structures a little later. But let us look into. But let us look into some of the examples where high-rise masonry have been used. High-rise masonry have been used. Now, let us first start with the abroad. Now, this is the building which was built in Chicago, the Monadnock building, which was built way back in 1891. Well, it's a 16-story high building. The thickness, was definitely had to be more because it was all masonry, which had to support the load coming on from the superstructure. Well, the thickness at the base was, roughly about 2 meters. This was built during the as a high rise during the early phase of high rise masonry. And subsequently, we can see a lot of examples like the one which you see here, wherein it was built in Switzerland. Very interesting to note that during the 1950s, where Switzerland or even Denmark did not have a steel industry of their own, had to have built, let us say 13 to 18 story buildings using, the masonry blocks. Well, what you see here is the one which is built in Switzerland. You can see some more in the Europe. That's the one which on your left is the one built in UK and Denmark. Well, the wall thickness is considerably low because the achievement in the strength or due to the better blocks manufactured, one could significantly reduce upon the thickness of the walls. The one what you see is built in the 1960s. The thickness is ranging between 210 to 355 mm. Well, this is another built in US, Chicago. This is not only designed for the vertical loads, but it's also designed for wind load. And you can imagine that the thickness is just 305 mm. You can imagine what would be the strength of the block in order to achieve such slender sections. This is another example from the US as well, built in Cleveland. On a local front, on an Indian context, yes, there have been buildings which have been built using, hollow concrete blocks, like the one which you see here. This is a building, 9-story building, which is being built in Nashik, which is a hotel building. And the one on the left is a 6-story high-rise building built in Mumbai by the architect, Mr. Ganesh Kamath. And the ones which you see on a very local front, where this is a building very close to Bengaluru in Mysore, where a 2-story, hollow concrete block masonry building has been built. This is a residential building built in Bangalore. You can notice that, because of the advantage of having larger holes in masonry, particularly hollow concrete block masonry, well, if you want to make it good in lateral loading also, well, one can go ahead, reinforcing these masonry vertically, and depending on the design, you can, place nominal reinforcement as per the requirement, and one can go ahead with the reinforced masonry, which will not only be good in vertical loading, but also it would reasonably withstand lateral loading as well. Now, having looked into some of the examples for high-rise, let us look into some where composite masonry units have been used. Well, the one which you see here is a composite masonry built using stone and brick. Likewise, you have, this is very interesting. This is a filler slab. Now, we have seen a lot of blocks or the masonry units, which, have been used to construct only the vertical walls. But what you see here is a roofing which has been constructed using a stabilized mud block. The concept is very clear here. It works on this concept, like let us say we have a rectangular RC slab, and when it is being loaded from the top, we obviously have tension at the bottom, and of course the compression at the top. Now, one thing which we know about concrete is concrete as it is not good in not that good in tension, although it is very good in compression. Well, if that is the behavior of concrete, then one can afford to remove the concrete which is in the tension zone of the slab and replace it with another masonry unit. Let us say in this case we have a stabilized block, which I had mentioned in the beginning. Well, this part of the concrete is replaced with blocks. And of course, there would be obviously tension at the bottom. So we will leave the tension to be taken by the reinforcement, which can be placed or can be designed to be placed in between the two, rows or columns of these blocks. What are the advantages? Yes, it would look, the temperature the transfer of heat would definitely be better. As we are looking at a material which is an earthy material, there'll be a less amount of heat transfer. Well, architecturally, aesthetically, it looks much more pleasing. And another thing, maybe if the workmanship is good and one can go ahead without even plastering the roof and maybe just finishing the slab, and it would just look very aesthetically better as well. So this is also an option where the masonry unit not only is being used for the walls, what you see here, but also you see it is being used as a roofing material also. Well, you can also have what you call the flat panel. Well, the flat panel, which are maybe prefabricated elsewhere, and then it can be brought to the site, and then just have to place these panels as a roofing material, of course, with the beams. Well, if one wants to use an arch kind of roofing, well, you have an option of making the panels again, and one can also have a jack arch roof. This is used using the masonry, and then some more examples where stabilized mud blocks have been used to have the jack arch roofing. Some more examples again. This is a beamless jack arch roof slab, and moving forward. Well, talking about some more examples with SMB. Well, this is another building in Karnataka where a 4-story stabilized mud block masonry has been built. You can see that it is architecturally pleasing. Well, I think you can also notice that the plastering is avoided and making it that much more efficient because of the less usage, and maybe it could be worked out to be more economical as well. And the good part is that it consumes far lesser energy and lesser CO2 emission, as discussed in the previous in the beginning slides. Some more examples. This is a school building in Tamil Nadu where the stabilized mud blocks have been used, and this is a vault. This is a vault where again which is being built using the stabilized mud block. Well, if one wants to look at the construction, well, it's quite simple, where you have a movable template, well, which is being traversed from one part of the slab, one part of the roof, and you just have to place your blocks over the template with proper locking, and then the vault would be finished. This is another example of a building in Sholingur, Tamil Nadu, where a vaulted roof has been built using burnt bricks. Well, a dome, the masonry is not restricted for vertical members as walls or horizontal members as filler slabs. Well, you can build curved roofs as well. Well, one classical example you can think of is a dome. Now, this is another example where a dome is being constructed using the masonry. Well, this is another example where, for a residence, a stabilized mud block dome of about 7.5 to, let us say, 8 meter dia has been constructed. Well, even as we did mention in the beginning, well, even for the construction of dome, we do not, unlike the RC structures, we do not require formwork as well. The concept, the technology is very simple, wherein you just have a single rod, which is serving the purpose as a guide. Well, this particular rod is just pivoted at the center of the dome, and using this rod as the guide, all you have to do is just keep on placing the blocks and go ahead with the profile, whatever you require. The rod can be lowered or can be heightened based on what is the rise of the dome which one wishes to have. If you want to have a shallow dome, well, you just have to lower your fossa of your point, the center point of the dome. Well, this is the finished product, finished building of the same building which I was talking about. Well, if you want to cover it, if you want to have it as a curved roofing in the interior, it could be that way, and outer and an exterior, if you want to have it as a Mangalore tile covering, one can go about doing it, depending on one's requirement. Where for the same dome, you have a Mangalore tile covering which is being done. Well, this is another building, burned gray bricks, again about 7 meter being built in Bangalore. Looking at the construction of dome, I think one can look at constructing, let's say, a spherical dome. Well, a spherical dome can best fit in a plan which is, let's say, square. Now, if I want to have a curved roof, but then I do not have a plan which is in square. Now, let us say if I have a rectangular plan. Now, again, you want to go about constructing a dome. For such reasons, one can maybe choose what you call as a dome in ellipsoidal shape, or if I can say an elliptical dome. On that note, we had one project student who wanted to work on that in RV College of Engineering, Bangalore, where we went about attempting to construct a dome in a form of an ellipsoid. Well, the idea is quite simple. Well, it's basically a prolat spheroid, where if you are looking at the plan of the plan and let us say a section along the major axis, it would look elliptical. While if you're taking a section along the, let's say, minor axis, it would shape of a semicircular. Now, and based on the geometry, one can arrive at what you call these 2 points as the point of foci, and you have these points on the foci. What we did was we just erected piers here, depending on what is the span. I think we took 4 meters as the major span and 3 meters as the minor axis span. And then the distance between the 2 piers were all calculated, and then we could have these shape as a supporting member. And using the foci, what you see here, these are the 2 piers of foci, and having a constant thread, where one end of the thread is connected to one foci point, like what you see here, and other end of the thread connected to the other point of the foci, and just pulling it out. And along this profile, you will be able to trace the what you call the ellipsoid in plan. Now, this is what was attempted, and I'm happy to also say that this was purely attempted by one of my students, and in fact he did the construction also himself, it is always one would say experiential learning is always appreciated. So on that note, he wanted to do it himself, and that is where we could complete this dome. And what you see here, well, as you are going ahead with construction of dome for let us say subsequent layers, this is the first layer. As you go above, obviously you will have the curve, and as you're going inwards, the blocks which you are trying to place here have to be supported. Now, in order to support that, we have the steel hooks which are in S in shape. Now, these S-shaped hooks, what it would do is it would counterweight the blocks which are in position with another brick here. So while this construction goes for one perimeter, well, the blocks would have sufficiently set. Well, number of layers he went about doing it, and these are the various stages of his construction. He's the student who has done this, and the counterweights here. You can see the counterweights here, which are trying to counteract the weight of the blocks which are just placed in position. Well, the product, one could imagine, well, this is the interior of the dome, and this one could imagine this is the final product what we would got what we had. As I said, well, along the major axis, it is that of elliptical in shape, while you are looking to take a section along the minor axis, it would be a shape of a semicircle. Now, if you want to maybe not have it as a dome of such big rise, one can make a shallow domes by just lowering the position of the foci. So if you just play around with the position of foci, what I'm trying to say, you and of course coming back with the distance of the foci, one can construct domes of shallow depth as well. Now, talking about the innovation, well, I think it is not complete unless we talk about the famous architects who were behind constructing some of the famous structures, if I can say that. Well, one cannot forget architect Dept, who was an Uruguayan architect. Well, during his tenure, that's during sometime in the mid 20th century, he has come up with wonderful structures, very innovative, where the one which you see here is actually a masonry water tank. Of course, it is reinforced. Well, we have seen reinforced concrete structures and its potential, but masonry is also not far behind. When you are looking at proper design and proper placement of reinforcement, one can achieve wonderful structures like what you see here is a masonry water tank which was built in the mid 20th century. During the same time, the same designer, you could see this cantilevered petrol station, what you can say, a cover where you can imagine what is the kind of cantilever it has. You can say that the technology used was again a combination of reinforced and pre-stressed. We have seen pre-stress concepts being used very extensively nowadays for concrete structures, but masonry also can be pre-stressed, and such structures are quite possible. These are some more examples of the same designer. Well, this is a shopping center in Uruguay. This is a church. Again in Uruguay. If you just key in the name of this designer, I'm sure you can see a lot of examples which are of great interest, for a structural engineer, and one can appreciate such structures being constructed, with masonry. Well, how can one also forget Antoni Gaudi? Some of the structures which was constructed maybe century, or you can say a late 19th century, we have such fascinating structures which have been designed by this famous architect. He was a Spanish architect during that period. Well, this is what you have, a school building. It's not restricted to being only used as vertical, horizontal. Well, you can construct, corbels, say, arches, using masonry. All these pictures talk by itself, the potential of masonry structures. And remember, these were built, maybe more than a century old, maybe 150 years old. And this is a building in Barcelona, which is called as the La Pedrera. It's also commonly called as Casa Milla. This was purely built using limestone blocks, maybe during 1906 to 1912, and it is sometimes also referred to as stone quarry. Now this has all become heritage structures, where it has become a tourist place, which also hosts a lot of commercial, social and cultural activities. you can see that it is neither it is curved kind of a construction which has been made. Well, this is a very classical example. This project was the last uncompleted work of Antonio Gaudi. Well, however, this part of the the crypt was actually they could complete it. You can see that these are all inclined in plan. One can imagine the kind of technology, the kind of design which is being behind to get such fascinating structures. Although the original the building was to be a church, but later it was converted to be a crypt in this place which is about 23 kilometers down south of Barcelona. Well, these are some of the structures. I'm sure if you just key in these are likewise many such architects or designers who have very innovative structures which have been built using the concepts of masonry structure. This comes these points. I think we could appreciate, or we could see that what is the potential of masonry structures. In terms of structural as well as in terms of architectural. Now, I would little extend my presentation in order to look at how do we go about assessing this masonry strength. What are the ways in which I can find out the strength, and adding to that, I will try to maybe in a nutshell try to also explain very briefly what are the guidelines as per 1905 and how do we go about with the design of a masonry structure. Now, if I have to, let us say, assess the load carrying capacity of the masonry structures, well, there are three possible ways. It is first, it would be to test the masonry constituents. When I say masonry constituents, it would be testing the masonry units, and of course, the one which is binding them, that is the mortar. Secondly, one could test the masonry prisms or wallets. What are prisms and wallets? We will discuss a little later. And the third option, which is the most preferred one, if one can afford it, if one has the facility, well, the best way to do it or test a masonry capacity is to do a full-scale wall specimen. Now, when I say full-scale wall specimen, what I mean is a story height wall which can be tested. Story height, let us say, if I'm looking at a conventional residential building, I would look at a height of, let us say, 3 meters. Well, if I can have the facility to test full-scale walls, well, that would be the best option, because it will give you a more realistic, what I can say, understanding of the performance of masonry, because it takes a lot of factors into consideration which we will discuss, and not only that, very importantly, it takes the effect of joints, because any structure, especially masonry structures, it is the joints which which also decide upon the load carrying capacity, joints and the number of joints which decides upon the load carrying capacity of the masonry. Now, how do we go about it? Let us go in one by one. Now, if you have to test the masonry constituents, yes, of course, I'll have to test the masonry units. Well, what are the tests one have to do? The physical tests, and of course the structural properties. Now, what are the tests one can do for physical? Of course, one has to know what is the water absorption of the block, what is the density of the block, what is the initial rate of absorption. And also structurally, one has to know what is the strength of the block. Okay, and apart from that, we go about looking at the characteristics of the masonry units. Secondly, we'll also have to test upon the mortar characteristics. Now, because this is the one which tries to test the block units. Now, again, compressive strength, flowability, stress strain characteristics these are some of the tests which one has to perform when we talk about the mortar. The second option, of course, is to test the prisms. Now, what are prisms? To understand prisms are basically, I can say short walls. short walls of certain h by t ratio, where the h by t does not exceed, let us say, 6. Well, these are the elements which have been constructed keeping the blocks one over the other, like a stack bonded prism, with of course the joints. And then the other option, if you also want to take the vertical joint also into account, well, then you can also have it as an English bonded prism. The objective is to, again, test for its basic properties, compressive strength, modulus, and of course the stress strain characteristic of the blocks. Although although this could be the general kind of test for any unit, I would try to show the test results of certain amount of work which we did in RV College of Engineering. Well, this is how typically a prism would look like. As I told, the prism is restricted. If you have to call it as a prism, well, you can go up to h by t of, let us say, 6 slenderness ratio. Well, typically you can have it as 3 block. You can have it as 5 block prism. And we were fortunate to have this kind of a facility at RV College of Engineering. We call this as a test floor. Well, this is a facility which maybe can be used for testing any structural element, be it a slab, column, anything. The capacity was something like 2,000 kilonewtons, 200 tons. Well, we could use this facility to test the prisms for its compressive strength and other properties. Well, we were fortunate to have a funded project from VTU where we could erect a closed frame exclusively for testing the tall walls. Well, this is a wall which we have tested, which is a wall of height 3 meters. And well, it requires a certain amount of arrangement which has to be done. Well, in order to look at the boundary conditions, it's assumed to be laterally and rotational restraint at the bottom. Well, in order to have it only laterally restrained at the top, well, we have an arrangement with a spring and a roller, which will make sure that you have a lateral restraint, whereas there is no rotational restraint at the top. And in order to make sure that the loading is uniform, what we did was we had a staircase system of loading where the load through a closed frame was transferred to 2 different tiers of loading, and transferring the load on to the masonry unit as a uniformly distributed load. Because of want of time, perhaps I'm afraid we would not be I would not be able to share the results of this, but certainly about the prisms, we would definitely look into some of the values. These are some of the factors which I did mention. If you are trying to test the full-scale walls, well, of course, the masonry units, the mortar strength characteristics are the primary factors for sure. And apart from that, the slenderness and also the eccentricity of loading play a very important role. Now, what is eccentricity and slenderness? Now, let us understand it with this sketch here. Now, let us say if I have a single block which I'm trying to test it for a concentric. When I say concentric, it's a central load. Well, obviously, I would get 100% strength of that particular unit. Well, if I just place these units one above the other, making it a little more, what you can say, increasing its slenderness, in other words, increasing the h by t ratio, and again, let us say I'm trying to apply a concentric load. Well, you would definitely, because as the height increases, it's a general phenomena, one would definitely expect a reduced strength. Similarly, if I'm talking about eccentric, what does eccentricity mean? Well, the loads are not acting at its CG. It is being placed at a certain distance away, which can be expected in a structure, any structure for that matter. Now, if that is the case, even though it's a small unit, but if the loads are not concentric but eccentric, then again, there is a reduction in the strength. And if you have the same load which is being applied, eccentric load, and along with that you have a taller wall, obviously there's a further reduction in the strength or the capacity of the wall. Well, this is what sums up these 2 points. That is that if it affects the slenderness ratio as well as the eccentricity of loading, and of course the boundary conditions. And apart from that, very important in masonry is the effect of workmanship. If the workmanship is not proper, then definitely one can expect the strength to be hampered, or there would be an influence in the strength of the masonry. Now, as I did mention, I said that I would be sharing a certain results of what we did for concrete blocks. I have just specified to the concrete blocks. Well, these are the cellular blocks, and these are the hollow concrete blocks. Now, if you remember in the beginning, I tried to distinguish what I mean by cellular and what do I mean by hollow. Just to repeat the fact, if I have a concrete block with smaller or rather smaller diameter of hole but more in number, then I would call it as cellular block. Well, if I have larger holes, and then that is your conventional hollow concrete block. Well, the first initial rows talks about its physical properties, what's its dimension, what's its density, what is its initial rate of absorption and absorption itself. And of course, the more important parameter here is the structural properties, where you see that it is around 7.06 MPa for a cellular block, and we have looked upon two different sizes, which is 150 and 200 mm blocks, which are giving 13.77 and 6.6 MPa as the strengths respectively. And of course, one would also want to know what are its elastic properties, and that is where we also try to test for its, tangent, Young's smartness as well. We also had to test for prisms. I will tell you why this test is required a little later. But yes, as we said, we wanted to also look into the, strength of 3 blocks prisms. Well, again, the same blocks were used for same sizes. You could see that, the strength was 3.91. There is definitely a reduction, because as you increase the height, obviously you can expect a reduction in strength. That is what I said. And 5.41 is the prism strength, average prism strength for about 5 blocks. You also see in the last row here, there is something called as corrected prism strength. Now, what is this corrected prism strength? Well, this is a provision, or this is a recommendation from the code, where it says all the prisms have to be normalized, the strengths have to be normalized for a slenderness ratio of 2 for the normalization of prism strength. On that note, we will also discuss how much is the prism strength and what is the correction factor one has to apply for a hollow block. Although now I would just leave it at here, like the corrected prism strength is 4.6. I will definitely come back to this value. How did I get this factor? A little later, my friends. Now, going forward, very briefly, well, what is the code? Well, it is Indian Standards 1905. Well, this is the code which one has to look for if one has to design a masonry, an unreinforced masonry structure. Well, it was first published in 1960. It has it was revised 3 times and was reaffirmed in 2002. Like a separate handbook for code for RC, we have a separate handbook for masonry structures as well in SP 20. And this is a code which provides recommendations for load bearing and non-load bearing walls for unreinforced masonry structures and for static loads only. Well, the philosophy of design as per the code is very simple. The philosophy which is followed is allowable stress method, or what you can say as the working stress method. Well, if you want to design it for seismic loading, well, there is a reference to IS 4326. If one wants to do a seismic design, one can refer IS 4326 for for strengthening unreinforced masonry for the seismic resistance. Now, as we all know that what is the fundamental principle behind the working allowable stress method is that you will have to find out the actual stress. Now, what are actual stresses? Stress by definition is load over area. Now, if I have to find out what is the actual stress, I would want to know what is the load coming onto the wall. And then, of course, dividing it with the area will give me the actual stress. This actual stress has to be compared with something called as permissible stress. Now, how do I find out the permissible stress is the next question. Now, the code also, of course, before we go on to the permissible stress, well, the loading, the dead load, the live load is all as per because I'm looking at an RC slab here. So the loading is as for RC structures where you will refer IS 875 for its various categories of loads. Now, and also before we go on to the permissible stress, one has to understand if I'm looking at the load dispersion for a wall, I would be looking at a dispersion angle of not more than 30 degrees. Where do we come across this? I will talk about it a little later, but for now, I would like to mention that you would be coming up with the dispersion angles whenever you have an opening in a wall. Let us say you have a window or a door, then one has to look upon what would be the angle of dispersion of vertical loads on walls when such a scenario occurs. Well, looking at design, like an RC design, one has to look into the effective height of the wall. I will not go into the details of it, but as we all know, like in RC or the simple column analysis, it all depends on what are the support conditions. Likewise, based on what is the support conditions, one can arrive at whatever is the recommended effective height of the building. Now, well, this is the screenshot which I have just taken it from the code, which gives you the guidelines, what has to be the effective height. Now, coming back to our permissible stresses, because this is the one which we have to compare with our actual stresses. Now, the code says that it can be calculated by these parameters. Now, what are these parameters? The first is the basic compressive stress. Now, what is basic compressive stress? We will talk about it. Well, these basic compressive stress has to be multiplied with certain reduction factors. Now, what are these factors? One is called as the stress reduction factor, depending on the slenderness. Other one being the area reduction factor based on the shape of the block. And the other one, the last one, which is called as the shape modification factor, depends on what is the shape of the block. Now, very briefly, we will just go into it one by one. Let us look at basic compressive stress. Now, where do I find basic compressive stress? Now, there is a chart or a table given in the code where it talks about basic compressive stress for those blocks where the height to width ratio does not exceed 0.75. Now, this table definitely for that reason can be used only if your block has a height to width ratio when it is being laid. The height of the block to the width of the block when it is being laid, it should not exceed 0.75. If that is the condition, knowing what is the mortar we are trying to use and knowing what is the block strength here, one can arrive what would be the basic compressive stress. Well, this is one option to find out the basic compressive stress. Looking at what is the other option, the code also says, now what happens if h by t of the unit exceeds 0.75? Now, in that case, well, the code says if you have to find out the basic compressive stress, all you have to do is multiply this value of the prism strength which you obtain experimentally with 0.25. In other words, all you have to do is divide the prism strength by 4 in order to get the basic compressive stress. Okay, so like if I just quickly go back here, now this was the strength which I was talking about. If you remember, I told you that this is the prism strength, which is 4.6, and I called it as corrected prism strength. Now, all I have to do if I have to get basic compressive stress is just divide 4.6 divided by 4 or multiply this with 0.25, which will give me the basic compressive stress. Now, that would be the value. Now, how did I get 4.6 is another thing which we have to understand, because we got this 4.6 based on the experimental value of 5.41. Now, going back to the same slide here, if you look here, there is another table which talks about the correction factor for the prisms. As I told you, it is normalized for h by t of 2. In that note, going back again very quickly, 2.94 is my h by t. H by t, how did I get 2.94? Because it was a 3-block prism. So one above the other. So it is, let us say if it is a 200 mm block, you know, let us say 203 times with 2 mortar joints will give me a certain value of h. If I divide it with 200 mm thickness, will give me this value of 2.94. And all I have to do is go back to that table and look at this. What is the value for 2. Let us say 94. I always, it permits interpolation. I can always find out the correction factor and then go about there and use it for the correction factors to be applied as applicable. Now, well, we finished with the first part, which is to find out the basic compressive stress. Now, what about the factors? Now, factors, as again, there are tables mentioned in the code. Well, as I said, KS is something on stress reduction factor. Now, what does it depend? It depends on the slenderness ratio and eccentricity. Now, slenderness ratio, how do I get? I just take the height of the wall divided by the thickness. I would get the slenderness ratio. Let us say if I'm not looking at any eccentricity, only concentric. Let us say I take the eccentricity as 0 or as applicable, then one can get what is the slenderness, what is the stress reduction factor from this particular table 9, my friends. And then the area reduction factor. This particular factor takes into the smallness of the section of the block, and it's applicable where the section is less than 0.2 meters square. The area of the section is less than 0.2 meters square, well, which can be calculated using this particular equation. All you have to do is find out what is the area of the block, multiply it 1.5, then add 0.7, one can arrive at Ka. Finally, we also have to look at the shape modification. It takes into the shape into account as the very name indicates. And then you have to look at what is the h by t ratio. So the table gives you the h by t ratio along for the strength of the blocks which you have found out the compressive strength of the blocks earlier. Knowing what is the compressive strength, what is the ratio, one can find out the shape modification factor, Kp, as well, my friends. Now we have this fundamental equation. We know how to find out sigma actual. We know how to find out sigma permissible. Now, just to wind up here, let me take a small example of let us say a multi-story building. Now I have here a multi-story building. I've just taken a random plan. Well, this particular plan we have, luckily a symmetrical plan here, and which is divided into block A and block B, let us say. And this, let me concentrate on one of the blocks as it is symmetrical, and it is being, divided as panels and walls. I have given the naming for each of the walls as wall A, B, C. And for our design, let me choose this one. Because of want of time, I don't want to go into the other walls, but I've just taken one solid wall here, which we would very quickly try to look at the design of it. Sir, do we still have time? Hello?
Yes, sir. Yes, sir.
Yeah,
yes,
I'll
sir.
take a maximum 10 minutes more.
Yes, sir. Yes, sir. Continue.
Yeah. So what is the calculation involved? Well, the design, it's like any conventional, because as I mentioned earlier, we are looking at a conventional RC slab, which has to be supported by our masonry. Now, let us assume a slab thickness of 0.125 meter, the thickness of the wall as 0.2. Well, the density of RC, as we know, 25, and then the density of masonry. Now, where did I get, what is the masonry I'm trying to use? Well, I'm trying to use the density of hollow concrete block masonry, which is the one which I mentioned in the table, where the density was around 12 Newton per kilonewton per meter cube. Well, of course, the height of the floor is 3 meters. And let me look at what is the feasibility of the one which I tested, if it is okay for, let us say, a G+3 or a 4-story building. The calculations of slabs goes as usual, where you will have to find out the dead load, thickness into the density, the floor finish, depending on what is the kind of building, the live load based on what is the usage of the building. One can arrive at what would be the total, floor slab load, which is 6.125 kilonewton per meter square. Now, if I have to look at for a roof slab, obviously I would maybe reduce upon the live load, and then maybe by another 0.5 kilonewton per meter square, let us say, I would end up getting a roof load of 5.625. Now, if I'm looking for one floor, 1 plus 1, let us say it would be a combination of these two, like what I have here. Now, going back to my plan, now this is the wall which I have identified. Now, the panel which the wall has to support is panel D. The dimensions of the roof is 3.94 and 3.56. So this is the panel. So I go back here. It looks like it is a two-way slab, which it is. Now I'm trying to support a wall on this face of the slab. Now all I have to do is try to find out what is this area of the slab which this wall has to support. Going with the fundamental understanding of our yield line analysis, this is the triangular portion which has to be supported. So I would go with finding out what is the area of this triangle. I would find out the area of this triangle with this yield line specifying me the angle. Now all I have to do is find the area and divide it with the length of the wall so that I get per meter length of the area per meter. Having known what is the area, we have previously calculated what is the load. Now all you have to do is now multiply the area in meter square per meter into the load which is in kilonewton per meter square. Meter square gets cancelled. So I have the floor load as 5.39 kilonewton per meter, and from the roof I have it as 4.95 kilonewton per meter. Now this is a per meter uniformly distributed load which the wall has to resist, my friends. Now, if let us say I take a ground floor plus 1, I just have to add these two as I told earlier, which comes up to this figure. Now, let us say I want G plus 2. Well, you just have to take twice the intermediate plus 1 roof. Likewise, my intention was to have a G plus 3. So I have it as 21.12. That is 3 times intermediate floor, 1 time roof load, giving me this value of 21.12. Going ahead, now this section I told you I have selected a solid wall, although not all we will not be fortunate to have all walls as solid walls. We will definitely have some openings, windows or doors. Because of want of time, I could maybe not touch upon that. It would require a little more time. So I have just simply taken a solid wall for our understanding. Let us say this is the section of the wall. Now, let me first find out what is the actual stress. Let me convert all the UDLs into the point load. Now we saw the slab load, which we calculated here, 21.12, which is for G plus 3, into the length of the wall, which is our 3.56. Now I have converted the UDL to a point load. Similarly, I have the wall. One wall have to be resting the other. So there are 4 such walls. So 4 walls into the length of the wall, into its thickness, into the height of each story, into its density, which is 12, giving me this value of 102. Then of course, you have a certain amount of slab resting on the wall, which has not been accounted. Let us say, although it's a very small value of it, let me also take that also into account. Again, there are 4 such slabs, 3.56, thickness is 0.2. The slab thickness was 0.125, 25, the density of concrete, giving up a lower value. Nevertheless, it's been incorporated. So the total load is 186.6. Now, the stress, we know load divided by area. We have the load in kilonewton and the area. Now, what is the area? Very simple. It is 3.56, the length of the wall, into its thickness, as we have assumed 0.2 thick wall. Well, the thickness is 200 mm, and you have the load in Newton now, and the area in mm square, giving a value of 0.26 Newton per mm square, my friends. Now I have with me the actual stress ready. All I have to do is now compare it with my permissible stress. Now permissible stress, as we said, I will have to take the basic compressive stress, and then we'll have to take the area reduction factors, or not only area, but then all the three factors. First, one by one, let us first find out the shape reduction factor. Shape reduction factor, well, this is the one. It requires you to know that what is the slenderness ratio. So we will simply go and find out what is the slenderness ratio. Well, slenderness ratio, we know by definition, it is nothing but the height of the wall to its thickness. Now height, I cannot take the actual height, but I'll have to take the effective height based on the support conditions. Now 3 meters clear height plus your slab thickness 3.025, based on whatever support condition I have taken here, 0.75 h times h as effective height, then you get 2.34 meters, which is divided by the thickness, giving me the slenderness ratio of 11.72, my friends. All I have to do now is go to this table and find out for a value of 11.72, I have the choice of interpolation, and I can maybe take it as 0 eccentricity, or usually when it is an exterior wall, they prefer it to be taken as 1/9 of an eccentricity. So therefore, based on that case, one can arrive at what would be the value of this slenderness ratio. It is 0.847. Also Ka, I told you it is 0.7 plus 1.5 times the area. You know what is the area of the block? You multiply with 1.5 times plus add another factor of 0.7, you will get the area reduction factor, which is here, my friends. And then finally the shape modification factor. Now this one, and based on what is the strength, where do I get the strength? I will again go back to my experimental data and check what is the strength of the block which I had got, and then looking at what is the h by t as laid for the unit, I can arrive at what would be the shape reduction factor, as I have got here as 1.1, my friends. Now it's time to get in all of them together. As I told in the beginning, just a little while earlier, my friends, I have to multiply these factors with something called as basic compressive stress. Now, basic compressive stress, how do I get? I could have used this particular table, but then this particular table is for the units whose height to width ratio should not be exceeding 0.75. Now, unfortunately, our block is not having, or rather it's having a ratio of more than 0.75. So I cannot go with this table. This usually fits in for a brick masonry. Well, I'll have to go with the second option which I have, find out the prism strength, divide it with 4 to get the required basic compressive strength. So that's precisely what we will do. Go back here, look at what was my prism strength. If you remember, if you recall, it was 4.6, my friends. 4.6 divided by 4 is 1.15. Now this 1.15 is just multiplied with all the other three factors, and you get a permissible stress of 1.01. Now you can expect, because it's a solid wall, one can expect a larger permissible stress for sure, because there are no openings. So, I just compare with these two values. Actual stress, 0.26, permissible stress, 1.01. Well, the actual stress is less than the permissible stress, so therefore my wall is safe. Well, this is I tried to get it as simpler as possible, and the wall which was chosen also was a solid wall. So therefore, my friends, we ended up having this wall to be extra safe, if I can say so. Well, if you have other walls, like let us say, if I go back to the plan, let us say I have few walls here, wall D or wall C. Well, you see, my friends, for such walls, there are openings for doors and windows. Well, if that is the situation, then you cannot take the entire length of the wall as the one which is resisting the load. It has to be calculated for another length, which depends on what I mentioned here with respect to the dispersion of vertical load and the angle. So that's for another day, maybe. Because of lack of time, I think I would end up my presentation with this wall, and this is how we go about with the design. Well, at the end, I would fail in my duties if I did not acknowledge my academic mentor, Dr. K.S. Jagdish, who has been my academic mentor. I would always be thankful for all his inputs, guidance, and support throughout my academic career. And with this, this is the references. One can go about looking at most of the things with respect to energy. I've taken it from these references. Well, thank you all. I hope I have met your expectations, my friends. If you have any more doubts on this, you can always email me your questions. I will be more than happy to answer your questions. Well, I will leave it at this page with my email ID here. So if you have any doubts whatsoever, I will try my best to answer it. Okay, sir, Dr. Gupta, sir.
Sir, yes, sir.
Thank you very much, sir, Manjunath sir, for enlightening us with your vast knowledge. I hope participants have gained a lot from your presentation. Now over to Arun Kumar.
Sir, thank you, sir. Sir, thank you for briefing out on today's topic and for sharing your knowledge. It was very clear and precise. It was more informative, and once again, I would like to thank you for taking time out of your busy schedule, sir. And you have explained with an examples, designs, and you have referred many courses. So it was more informative once again. And now it's time to conclude today's webinar. And I kindly request our colleague, Mr. KIRAN, sir, to propose the vote of thanks. So once again, before a vote of thanks. Any questions pertaining to the topic discussed in today's session, I have been asked to drop in chat box, and few questions have been asked in the chat box. I would like to call upon Rajeshwari ma'am, Assistant Professor, Department of Civil Engineering, to ask the questions which is dropped in chat box. Over to you, ma'am.
There are a couple of doubts from the participants. Sir, I'll read out those questions to you one by one.
Yeah, please, ma'am, please.
First question is from Amit Pratap Singh. Can we build masonry structures in earthquake zone 3rd, 4th, and 5th? How ductility is provided to masonry structure to resist lateral loadings, because masonry is brittle in nature?
Yeah, that's a very valid question. I think everybody has a concern about masonry structure being very brittle. Well, yes, by itself, it is a very brittle material. But if one have to, design it for taking the lateral loadings, well, just masonry will not be enough. One has to go ahead with, going ahead with this option of reinforced masonry, where based on whatever is the design requirement, whatever zone as the panel as the person asks, one would definitely have to go with designing it as a reinforced masonry. Well, reinforcement along with masonry will make the element that much more ductile, and that will definitely be a solution for maybe taking up the earthquake loading as well. Apart from that, there have been a lot of other options also, like they have something called as confinement masonry. Well, if one have to go designing a masonry for resisting lateral loadings or earthquake loadings, then just masonry will not be enough. We'll have to go with a little more. We have to add a little bit of reinforcement with it, or maybe have some more options like the confinement masonry, which will be good enough in resisting the lateral loadings also.
Okay, sir. The second question is from Tushar Patel, What is meant by bimodulus composition of mortar?
Well, unlike concrete, we assume that the material is homogeneous, isotropic, material, because that's what we assume out of concrete. But when we talk about masonry, as I mentioned, it is a composition of two materials. One is a concrete, not necessarily concrete block, but any masonry unit. The other one is that of mortar. So each one have a different modulus. Well, that is one reason why we would look upon a masonry, which is a constituent of these two materials, having two different modulus. That is why we would look at it as a bimodulus material.
Okay, sir. The third question is from Sunny, sir. For masonry work with solid bricks, what should be the consistency of mortar?
Solid bricks.
Yes, sir.
Be it bricks or any block or any other masonry, the mortar is a very important parameter. Well, one can perform the flowability test from the flow table, and as per the literature, anything in the range of 95, let us say 100 to 110 flow is believed to be ideal, which can be used for the masonry. So anything between let us say 100 to 110 slump or the flow using the flow table, I think it would be good enough for any masonry, even if it means for a brick masonry as well.
Okay, sir. Thank you. The next question is from Sridevi ma'am. What about the water retentivity proportion in masonry construction?
That sometimes, in masonry that would maybe go as a drawback because, if the blocks are having a high water absorption, that would maybe one drawback of masonry, but that can be, addressed. I think the kind of technology we have in the block making, one can manufacture good quality blocks which have a very low water absorption, be it water absorption or even be it the initial rate of absorption. And with the kind of technology we have, the kind of manufacturer players we have, I think they are able to make blocks which are very good in terms of its water absorption, and to that extent even the retentivity of the water or the moisture within the blocks.
Okay, sir. One more question.
Yeah.
In brick masonry dome structure, linkage will occur due to rainfall. In clay brick have more moisture content, then what is the solution?
Sorry, I did not understand the first part of the question.
I'll repeat,
Yes.
sir.
Yeah.
In brick masonry dome structure, linkage will occur due to rainfall. In clay brick have more moisture content, then what is the solution?
What would occur because of the rainfall? Leakage, is it?
Leakage.
I think I doubt if it would leakage would be an issue in a dome. I don't know if I have understood your question right, but definitely there would not be any leakage, and it would be quite strong with the kind of blocks. Of course, when we choose the block for the the dome construction, we'll have to be a little bit careful about the kind of blocks. So with the good quality blocks, I'm sure even that problem of leakage or the retentivity of water can be addressed. It again depends on what is the type of block, and of course what is the kind of mortar. The joint and the will be quite strong, and I don't think there would be any issues with leakage unless the quality of the block itself is it's quite bad. But there is also, if you look into the southern India, southern portion of India, concerning the bricks, to be specific, not strengths are achieved as compared to the North Indian part, maybe because of the geometrical properties of the soil. But yes, one has to be sure about the strength of the block and the properties of the block before you go.
Sir, it is audible, sir. It's not audible.
Hello, are you?
Yes, now, sir. Now it's audible.
Is it audible now?
Yes.
Sir. Yes. Okay, sir. The next question is from Sahana. What is masonry width?
Masonry?
White.
Width. W-Y-T-H-E.
Yeah, masonry width, I think, these are actually rammed earth, if I'm not wrong. I think I have also come across this term if I'm not wrong, it is the rammed earth, basically, what one can understand with masonry width.
Okay, sir. One more question. Which joint should be avoided in brick masonry? Which bond is stronger in brick masonry?
Sorry?
Which joint should be avoided in brick masonry and which bond is stronger in brick masonry?
Well, for masonry to be effective, the fewer the joints, the better is the performance of the masonry. Based on the applications, I think one can go ahead with a particular choice. But if it is let us say hollow concrete block, well, one can go ahead with the stretcher bond. I think that is the one which will be the most effective as per my understanding.
Okay, sir. Are the geopolymer soil bricks cost effective?
Geopolymer blocks are the new addition, which is although you have geopolymer concrete, but then there have been a lot of research which is being done in geopolymer blocks. To be honest, I do not have much of a data about geopolymer blocks, but as far as I know, in terms of the strength, one can achieve 5 to 6 MPa quite easily. But the durability, their performance, and the other properties have to be evaluated, so to have a better understanding about this new addition of the masonry unit.
Okay, so last question. This question raised by KV Vijayendra sir, BIT College. So rather than precise consistency of mortar workability and pre-wetting of bricks is more important. I'll repeat once again.
Yes,
rather than precise consistency of mortar workability and pre-wetting of bricks is more important.
Yes. I totally agree with Professor KVV, who happens to be also my teacher at VIT. The pre-wetting of blocks have to be is a very important aspect, because if the blocks are very dry, it so happens that whatever moisture is with the mortar, there is a tendency that the blocks would try to absorb a certain amount of moisture, so making the masonry bond a little more brittle. So that would definitely affect the strength of the masonry. Yes, I totally agree with what Professor said, that it has to be pre-wetted so that it does not absorb any water from the mortar. So the mortar has enough water with it for the process of hydration. But that's another that's an important point. One has to be absolutely sure that the blocks have to be pre-wet and then used for masonry. But yes, when I said 100 to 110 consistency for the mortar, well, that is as per the literature, where that that kind of flow is good enough for me.
Okay, thank you, sir. Sir, one more last and final question. It's from Yatindra Sharma. So, which is the most cost-effective masonry or concrete work?
Well, you know, it depends on what is the kind of project which we are dealing with. You know, the concrete, no doubt, you know, there is a lot of what I can say advancement even in the production of the concrete and its constituents.
Hello, sir. Kindly unmute, sir. It's not audible.
Yeah, I think someone has muted it. Anyways, so what I was saying is, well, the concrete also, it all depends on what is the purpose of usage. Although concrete, there are a lot of advancement in the production of the ingredients of concrete also, which where they are also very, you know, very, they are taking a lot of care in getting down the the energy consumption or maybe the CO2 emission in the production of concrete also. So, you know, it would be it will all be dependent on what is the kind of project. Well, you cannot conclusively say, yes, this is better and that is better. Well, it is, even this presentation is not that, you know, it would not be a fair comparison between the two. The idea was to just project, because everybody tries to fancy RC structures for even, let us say, a one-story building or even two-story building. So I think, you know, when there is a alternative technology like you have it in masonry structures, then why not? And you know, sometimes, you know, the buildings, if it is become a trend, like, you know, the son does not want to live in the plan which the father has created. He would want to demolish the building and again go about constructing again a new one. So if this is the kind of thing, why do we want so much of steel, so much of concrete, which is a little more energy intensive material? Rather, we can, you know, have such materials, such alternatives which have been proven right from so many hundreds of years, and it has the technology, it has the potential, then why not use it? But to answer the question, again, it is very specific to the project. All I can say is, perhaps, you know, with the dome construction, which we tried, the ellipsoidal dome, we could you know, straight away get about, let us say, 40% reduction in the cost. That information I can share, because this is what we calculated for the ellipsoidal dome. We wanted, if we had to complete a concrete dome and compare it with the ellipsoidal dome which we have constructed, we could evaluate to have it as straight 40% reduction. I hope that answers the question.
Yes, sir. So thank you very much, sir. I think there are many more questions, but due to time constraints, we can't able to cover all those questions. Finally, I would like to thank you once again for giving your time, sir. Now it's time to
thank you very much.
Sir, now it's time to conclude today's webinar. I kindly request our colleague, Mr. Kiran, to propose the vote of thanks. Kiran, unmute Kiran.
Thank you, sir. Good afternoon, and all. Thank you for giving me an opportunity for entering the vote of thanks. Honorable Chairman, Srimati Rashmi Ravi Kiran Madam, Secretary, Mr. Tej Ravi Kiran Sir, and Director Dr. Purushottam Sir, East Group of Institutions, Bengaluru. Respected and most distinguished Chief Guest of the day, Dr. Manjunath S. Amalkar Sir, respected Principal, Dr. Channakeshwaru Sir, our beloved HOD, Dr. S NAGARAJA GUPTA Sir, honorable professors, participants, and my colleagues. It's my honor to propose a vote of thanks to all who have helped us in making this event grand success. First of all, I would like to thank our guest and speaker, Dr. Manjunath S. Amalkar Sir, for making excellent presentation and making this webinar interesting. Thank you, sir, for your informative session.
I would like
to express my profound gratitude to our management, director, and principal for their continuous support for conducting such event. I extend my special gratitude to Indian Concrete Institute, Bengaluru Student Chapter for their support. I would like to thank the chairman, Dr. L.R. Manjunath sir, and secretary, Dr. R.L. Ramesh sir, Indian Congress Institute, for their support. I extend my special thanks to Professor T.V.L. Rangnath sir, Department of Civil Engineering, Higher College of Technology, Sultanate of Oman, Muscat. I extend my big thanks to my colleagues for their support and contribution for making this event successful. And also, I thank our beloved HOD, Dr. M.S. Nagaraja Gupta sir, for his continuous encouragement and guidance. I especially thank the convener, Dr. M.S. Nagaraja Gupta sir, and coordinator, Mr. Arun Kumar and Mr. Sunny K, who are the backbone of the event. Thank you, sir. Finally, the wonderful participants who have turned up in such great numbers from various places. Thank you so much for your cooperation. Once again, I thank you all for your cordial cooperation and patience listening. Thank you, one and all. Thank you, sir. Over to you, Arun, sir.
Thank you.
Thank you. Thank you once again, Mr. Kiran, for rendering your vote of thanks. So thank you all the participants once again for attending, for your patience, for so much. And I would like to thank once again Dr. Manjunath S. Amalkar sir for giving your time and for sharing your knowledge.
Thank you, Professor Arun. Thank you.
Feedback will be shared in the webinar group as well as chat box now. Thank you. Thank you, Anand.